Welcome back guys. अब हम करेंगे current electricity and DC circuits question 17 paper 2 5054. Let's start. Question 17. Measurements are made of the current in a metal wire and the potential difference across it. Figure 10.1 shows a graph of the current against the potential difference for the wire. ठीक है ना? This is the current potential difference graph. State the relationship between the current and the metal wire. तो रिलेशनशिप बिटवीन द करंट एंड द मेटल वायर विल बी डायरेक्टली प्रोपोर्शनल। एक तो हमें इसकी ग्राफ से पता चल रहा है कि इफ वन इंक्रीजेस द अदर वन विल इंक्रीज एज वेल। दैट इज व्हाट डायरेक्टली प्रोपोर्शनल मींस। ठीक है ना? एंड ड्यू टू द ओम्स लॉ द करंट पासिंग थ्रू अ वायर इज डायरेक्टली प्रोपोर्शनल टू द वोल्टेज, सो दे हैव अ डायरेक्टली प्रोपोर्शनल रिलेशनशिप। ठीक है ना? तो आगे चलते हैं। State how the graph shows that the temperature of the wire does not change in the experiment. First of all, मैंने एक हिस्सा बाद के लिए रखा हुआ था। The current passing through a wire is directly proportional to voltage if the temperature is kept constant. ठीक है ना? Temperature is kept constant. अगर temperature change नहीं होगा तो the conductor will stay ohmic. It will obey the Ohm's law. But if the temperature is changed, the resistances will vary due to the properties of the metal changing. ठीक है ना? Property जब metal की change होंगी तब the resistance will vary. ये देख लेते हैं। एक ओमिक रेजिस्टर जो है इसका बिल्कुल स्ट्रेट स्लोप है, इसकी स्ट्रेट लाइन जा रही है। while on the other hand a non-ohmic conductor will be, it is curved. तो resistors that obey Ohm's law, any increase in voltage creates a linear increase in the current because they are directly proportional, while on the other hand resistors that do not obey the Ohm's law, any increase in voltage creates a non-linear increase in the current. ठीक है ना? तो yeah. Another wire of the same material has the same length as the original wire, but it has the half the cross-sectional area. Compare the resistances of the new wire and the original wire. ठीक है ना? हमने resistances compare करनी है between the new wire and the original wire. Original wire जो थी उसका cross-sectional area 1 था, और जो the other wire it has the half the cross-sectional area. समझ आई? तो क्रॉस सेक्शनल एरिया और रेजिस्टेंस में क्या रिलेशनशिप होता है? मैंने आपको क्या बताया हुआ है? इफ द एरिया इंक्रीजेस द रेजिस्टेंस विल डिक्रीज। रेजिस्टेंस विल डिक्रीज। समझ आई? दैट शोज दैट दे हैव अ इनवर्सली प्रोपोर्शनल रिलेशनशिप। तो कंपेयर द रेजिस्टेंसेस ऑफ द टू। अच्छा, तो इट ओनली हैज हाफ द क्रॉस सेक्शनल एरिया, मतलब area decrease हुआ है। when the area will decrease the resistance will increase, right? So it has twice the resistance, twice the resistance from the original wire. Since the area has halved, the resistance will double. ठीक है ना? On figure 10.1 draw the graph for the new wire. So the new wire has twice the resistance from the original wire. और जब रेजिस्टेंस ज्यादा होती है तब करंट क्या होता है? करंट कम होता है। जब रेजिस्टेंस डबल होगी करंट हाफ हो जाएगा, और जब करंट हाफ होगा तो उसके जो ग्रेडियंट होगा दैट विल आल्सो बी हाफ। समझ आई? अब मैं आपको एक और चीज बता रहा हूं। द रेजिस्टेंस हैज डबल्ड, एंड सिंस वी ऑल नो कि when the resistance is increased the current will decrease, right? And when the current decreases the gradient will be half of what it is right now. So ये देख लेते हैं हम। ये 0.4 पे है तो हम इसको अब 0.2 पे ले आएंगे, because that is what the signs are indicating. B. Three resistors are connected to a DC power supply as shown in figure 10.2. The electromotive force of the power supply is 6 volts. So this is a 6 volt battery power supply, I mean. And this is a 24 ohm resistor. This is a 20 ohm and a 80 ohm resistor in parallel to each other. ठीक है ना? Calculate the total resistance of the circuit. The total resistance will comprise of the 20 ohm resistor, the 80 ohm resistor, in parallel and the 24 ohm resistor in series. ठीक है ना, इन तीनों को अगर हम ऐड कर देंगे वी विल गेट द आंसर. बट फर्स्टली इन ऑर्डर टू ऐड द this parallel configuration to the series configuration we will have to calculate the total resistance in the parallel configuration. So 1 by r will be equal to 1 by r total will be equal to 1 by r1 plus 1 by r2 plus 1 by r3. ठीक है ना, एंड सो ऑन एंड सो फोर्थ जितने मर्जी आपको चाहिए हो. ठीक है ना, 1 बाय आर टी विल बी इक्वल्स टू 1 बाय 20 प्लस 1 बाय 80. 1 by 20 plus 1 by 80 will be equals to 0.0625. 0.0625 is equals to 1 by RT. RT ऊपर चला जाएगा और 0.062 नीचे आ जाएगा. RT will be equals to 1 by 0.0625. So 1 divided by 0.0625 will be equal to 16 ohms. 16 ohms will be the total resistance in this configuration. And if we add that to the series resistor, so we can get the total resistance of this circuit. तो ये हम ऐड कर देंगे सीधा सीधा. So 24. So this will total out to be 40 ohms of resistance in this whole circuit. The current supplied by the power supply. The current will be equal to V is equal to IR से हम निकालेंगे current, which will be 6 is equals to I हमारे पास नहीं है, R हमारे पास है 40. तो 6 divided by 40 will be equals to 0.15 amperes, which will straight away be the current. चेक कर लेते हैं एक दफा. 16 ohms और total 40 ohms और ये 0.15. अच्छा, the potential difference across the 20 ohm resistor. 20 ohm resistor के across कितना potential difference कितना है between the 2 points. First of all आपने देखना है कि इसका करंट कितना है. करंट हमने निकाल लिया है, करंट हमने निकाल लिया है, करंट हमारे पास आ गया है. तो अब हमने फिर से फॉर्मूला अप्लाई करना है, V इज इक्वल टू आई आर. V हमारे पास कितना है 6, आई मीन निकालने वाला है, V हमने निकालने वाला है. I हमारे पास कितना है 0.15. और पैरेलल कॉन्फ़िगरेशन की हमारे पास टोटल करंट कितना आई मीन रेजिस्टेंस कितनी निकली थी, इट वाज 16. तो 0.15 into 16 will give us straight away the answer, which is 2.4 volts. अच्छा, one key point whenever you are getting the potential difference across one terminal, right? एक आप जगह से potential difference निकाल रहे हो, फॉर एग्जांपल इधर से. Although you can see कि इधर 80 ohms का resistor और यहाँ 20 ohms का resistor है, they will still have the same voltage across them. ठीक है ना, they will still have the same voltage across them. और जो हम resistance इनके लिए लेंगे that will be the combined resistance which is 16 ohms. So you have to keep that into consideration. तो ये देख लेते हैं हम लोग 2.4. ठीक है ना. 3. The DC power supply is a battery that contains a number of cells. Each cell has an electromotive force of 1.5 volts. State what is meant by the electromotive force. Electromotive force को आप ऐसे represent कर सकते हो in this formula. Voltage is equals to work done divided by charge. And what does this mean? This means the EMF is the amount of work done required by the cell to move a unit charge around a closed circuit. मैं लिख रहा हूं इसको. EMF is the amount of work done required by the cell to move unit charge around a circuit. So as simple as that, that is what EMF is. आप इसको इससे भी represent कर सकते हो, but since they have given us this much space, so they require us to write this much as well. In the space below, draw a diagram to show how four pieces, four of these cells can are connected to make a battery of EMF 6 volts. Mark the positive terminal from the battery of the battery. अच्छा, first of all, I have made four cells. ये one cell हो गया, ये two cell हो गया, ये three cells हो गए, ये four cells हो गए. And these cells are connected in series. And when cells are connected in series, they tend to add up. They tend to add the voltage, right? So if we multiply 1.5 by 4, will we get the answer 6? Yes. And they have previously told us the each cell has an electromotive force of 1.5 volts. So अगर हम 1.5 volts plus 1.5 volts plus 1.5 volts plus 1.5 volts करें, that will equal to this diagram. And this will be the positive terminal because it has a long end, and this will be the negative terminal because it has a short end. In other in another argument to produce a battery of EMF 6 volts, 8 cells of EMF 1.5 volts are connected. In this arrangement, some cells are in series and some in parallel. In space below, draw a diagram to show how the 8 cells are connected to make the battery. अच्छा, first of all, यहाँ 4 cells बने हुए हैं, यहाँ 4 cells बने हुए हैं, and they each represent 6 volts, right? They each are representing 6 volts. So, अगर आप normally think करोगे, so you would think that they would add up, right? But in parallel, that's not the case. In parallel, the cells do not add up. The cells की जो voltage होती है, that stays the same. But what happens is कि उसके other benefits आ जाते हैं, right? जो होता है, it does not fail. Because अगर एक सेल इनमें से खराब हो जाता है, you can still have the other part of the circuit, right? You still have the other part of the circuit which you can rely on. So it is more reliable, right? तो फिर से यही पॉजिटिव साइड होगी और ये नेगेटिव साइड होगी. एंड अनदर थिंग इज नॉट अनदर थिंग, आई एम जस्ट गोना रिपीट व्हाट आई सेड कि ये 6 वोल्ट्स है और ये 6 वोल्ट्स है, एंड दिस विल नॉट एड अप. और जो ये करेगा, इट विल जस्ट प्रोवाइड अ लॉन्गर बैटरी लाइफ. स्टेट वन एडवांटेज ऑफ यूजिंग a battery made from cells in parallel rather than a single cell. It is because it will last longer. बस ये लिखते हैं, it will last longer due to there being more cells in parallel. It will last longer. If one cell fails, the other ones still work. ये हो गया है. और काफी ज्यादा मैंने आपको भी बताए हैं benefits of this. So that is going to be it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.